Okay, today we're going to be looking at momentum. Now, momentum is a word that we use a lot in English to basically mean anything where we describe an impetus being gained. So we can say, for example, that feminism gained momentum in the early 20th century, or the fundraising campaign needs to gain momentum to reach its goal. And when we say this, we understand what we mean by it. We mean that we mean that act of something getting more powerful, more strong, gaining support. However, in mechanics, we use momentum to mean specifically it's a measure of the impetus possessed by a moving object. And we are going to be considering the momentum that objects have and how momentum can be transferred to objects when they undergo collisions. So let's think about, let me get my, change the colour of my pen. So let's consider a man pushing a shopping trolley. And you're going to push it in this direction. Now, if to push that shopping trolley, you don't need to push it particularly hard when the trolley is empty. But now consider the man pushing his shopping trolley and it's full of stuff. He has to push harder to get that shopping trolley moving. And to explain this, we are explaining it's all to do with momentum. The mass of the empty shopping trolley is obviously less, so it's easier to push. The mass of the full shopping trolley is larger. So we can describe momentum as a body of mass m kilograms moving with speed v meters per second has momentum given by the mass multiplied by the velocity. So we can see with this that an object at rest will have zero momentum. So momentum is something possessed by a moving object. The units of momentum are Newton seconds. So this is momentum is mass times velocity, and momentum is measured in Newton seconds. Let's note momentum is a vector and it has the same direction as the velocity. And we're going to be considering just one-dimensional motion along the line that you need to work out whether the momentum is positive or negative. So we're not going to be, everything's going to be moving in a single line like what we've already been doing previously. So let's do a very simple example. Find the momentum of a body of mass 3 kilograms moving at 5 meters per second. So we know momentum is mass times velocity. The mass is 3, the velocity is 5, so that's going to be 15 Newton seconds. Let's consider another one. A ball of mass 50 grams, pay attention, it's grams, hits the ground with speed 10 meters per second, and it rebounds with speed 6 meters per second. Find the change in momentum. So 50 grams is the same as 0.050 kilograms. So you divide by 1,000. So that's really important when you're doing questions involving momentum, and some of the in the next chapters of the book, when you have to think about the mass of things. Always be aware of the units. We're dealing with kilograms, so if it's in grams, you need to convert it. So momentum before mass times velocity, so the mass is 0.05 and the velocity before it hits the ground is 10, so it's going to be 0.5 Newton seconds. And the momentum after mass times velocity, so the mass doesn't change, but the velocity is now 6, and it's in the opposite direction, so it's coming down. If this is the positive direction, the rebound is the negative direction, so it's going to be minus 6 meters per second. So that's something to really be aware of when you're doing these problems. Remember, momentum is a vector quantity, so we've got to be aware of changes in direction of motion. So it's going to be minus 0.3 newtons per second. So the change in momentum is minus 0.3 minus 0.5, so it's the momentum after minus the momentum before. If we use the if we use the positive here as a loss in momentum, so what we get here is minus 0.8 Newton seconds. So there's been a loss of momentum. So we do so the change of momentum is momentum after minus momentum before. So the after is minus 0.3, and then we've minus the one before, which was 0.5. So we've got a loss of momentum in this one because it's negative. If it was positive, momentum would have been gained. So I hope that makes sense.